Question number 39. A capacitor with a stored energy 4 joule is connected with an identical capacitor with no electric field in between. Find the total energy stored in two capacitors. We have U equals to Q square by Q square by 2C. So Q will be under root 2U into C. Here it is shown, this is a capacitor with charge Q and minus Q initially. When it is connected to the another capacitor, charge is distributed, so it becomes plus Q by 2, and again it get plus Q by 2 and minus Q by 2. When second capacitor is connected to first capacitor, the half charge of first capacitor will be shared by second capacitor. Hence Q1 equals to Q2 equals to Q by 2 or equals to under root 2 UC by 2. Now total energy stored in both capacitor, U dash equals to U1 plus U2, Q1 square by 2C plus Q2 square by 2C, or Q1 square is equal to 2 UC by 4 into 2C, 2 UC by 4 into 2C. Because Q1 is this value, so 2 UC by 4 into 2C plus 2 UC by 4 into 2C, or U by 4 plus U by 4, or 2U by 4 equals to U by 2 equal to 4.0 by 2 equal to 2.0 joule. Answer. Question number 40. Question number 40. A capacitor of capacitance 2 microfarad is charged to a potential difference of 12 volt. It is then connected to an uncharged capacitor of capacitance 4 microfarad as shown in figure. Find A, the charge on each of the two capacitors after the connection. B, the electrostatic energy stored in each of the two capacitors, and C, the heat produced during the charge transfer from one capacitor to the other. Let initially it is given, so C and V is given, so Q will be C into V, 2 microfarad into 12 volt equal to 24 microcoulomb. Now it is this is connected to another capacitor with capacitance C2. So let after connection the charge on the two capacitors are Q1 and Q2. Since the potential of capacitors will be same, hence V1 equal to V2, or this implies Q1 by C1 equals to Q2 by C2. This implies Q1 by Q2 equal to C1 by C2, or 2 microfarad by 4 microfarad equal to 1 by 2, or this gives Q2 equal to 2 Q1. This is question 1. Now charge, we have initial charge Q equal to Q1 plus Q2, so Q1 plus 2 Q1 equal to 3 Q1. So we can get Q1, the value of Q1 as Q by 3 equal to 24 microcoulomb by 3 equal to 8 microcoulomb, and the value of Q2 equals to 2 Q1 equal to 2 by 3 Q equal to 2 by 3 into 24 microcoulomb equal to 16 microcoulomb. Answer. B, we have U1 equal to Q1 square by 2C, so 64 by 2 into 2 into microjoule is 60 microjoule, and U2 Q2 square by 2C. Now value of Q2 is 60 microcoulomb, so 60 into 60 by 2 into 4 equal to 32 microjoule. C, heat produced equals to loss in stored energy. Heat produced is equal to the loss in stored energy, that is equals to a stored energy before connection minus stored energy after connection. So before connection our stored energy 1 by 2 QV minus after connection U1 plus U2, so 1 by 2 into 2 microcoulomb plus 12 volt minus 16 plus 32 microjoule, and solving we get 96 microjoule answer. Next question. A point charge q is placed at the origin. Find the electrostatic energy stored outside the sphere of radius r centered at the origin. Here it is shown the situation. This is a point charge q is placed and this is a sphere of radius r. Now the potential of the sphere A will be 1 by 4 pi epsilon naught q by r, and the potential of cell B, which is at infinity, will be 1 by 4 pi epsilon naught q by infinity equal to 0. Hence VA minus V, that is potential difference between these two, will be 1 by 4 pi epsilon naught q by r. Hence capacitance of the capacitor C equals to q by VA minus VB equals to q by, now VA minus VB using the value 1 by 4 pi epsilon naught q by r or 4 pi epsilon naught r. Hence this is the capacitance of a sphere of radius r with charge q. Now energy stored between A and B, that is outside the sphere A, equal to q square by 2c, or equals to q square 2 into 4 pi epsilon naught r, or q square by 8 pi epsilon naught r answer. Question number 22. A metal sphere of radius r is charged to a potential V. Find the electrostatic energy stored in the electric field within a concentric sphere of radius 2r. We show that the electrostatic field energy stored outside the sphere of radius 2r equals that stored within it. Again, this is a charged metallic sphere with charge q and its radius is r. This radius, this sphere is named A and this sphere is named B. Of this is the imaginary radius sphere of radius 2r. Now potential at surface of the metallic sphere A, we know that VA equal to 1 by 4 pi epsilon naught q by r. Let this is V, equation 1. And potential at B will be VB equal to 1 by 4 pi epsilon naught q by 2r, because radius is 2r. So 1 by 2 into 1 by 4 pi epsilon naught q by r, or 1 by 2 V equal to V by 2. So potential of VB is V by 2. So change in potential difference delta V will be VA minus VB, VA minus VA by 2, or VA by 2 equal to V by 2. So potential difference between these two spheres is VA by 2. Now capacitance of the spherical capacitor will be Q by delta V, or Q by VA by 2 equals to 2Q by VA. Second, hence energy stored will be 1 by 2 C into delta V square, or 1 by 2 into, using value of C, and value of C is 2Q by VA, to 2Q by VA into, and delta V is VA by 2, to VA square by 4, solving Q VA by 4, or equals to, and Q VA is VA by, or Q by 4 into 1 by 4 pi epsilon naught Q by R, using the value of VA. So we get equals to Q square by 16 pi epsilon naught R, or equals to, using the value of Q, values of Q is 4 pi epsilon naught RV. So 4 pi epsilon naught RV to the whole square by 16 pi epsilon naught R, or 16. So we have 16 pi square epsilon naught square R square V square by 16 pi epsilon naught R, or 16 pi epsilon naught and R. So we have pi epsilon naught R V square answer. Now B, VA equal to 1 by 4 pi epsilon naught Q by 2R, and VB equal to 0, and C will be Q by VA minus 4 pi epsilon naught into 2R. Hence energy stored 1 by 2 C into delta V square, 1 by 2 4 pi epsilon naught into 2R into Q square by 4 pi epsilon naught square into 2R square, and solving 1 by 2 Q square by 4 pi epsilon naught square into R, Q square by 16 pi epsilon naught R. This is question 3. Thus from equation 2 and 3 it is clear that the statement is true. 43, question number 43. A large conducting plane has a surface charge density 1.0 into 10 to the power minus 4 coulomb per meter square. Find the electrostatic energy stored in a cubical volume of age 1 centimeter in front of the plane. This is a conducting plane which I have given. Surface charge density is sigma, it is given. So electric field due to this plane sheet of charge, we know that it is equal to the sigma by epsilon naught. Now we have formula, that is energy per unit volume, which is called energy density, is equal to the U equal to 1 by 2 epsilon naught E square. This U is equal to the du by dv, that is energy per unit volume. Du by dv equals to 1 by 2 epsilon naught E square. Hence du equals to 1 by 2 epsilon naught E square, 1 by 2 epsilon naught E square into dv. Now it is a this is a square of radius A, so its volume will be AQ. So we can place the value of dv as AQ. So U will be 1 by 2 epsilon naught E square into AQ, and now use the value of E, 1 by 2 epsilon naught, and value of E is sigma by epsilon naught. So sigma square by epsilon naught square into AQ, 1 by 2 sigma square AQ by epsilon naught. Answer. Question number 44. A parallel plate capacitor having plate area 20 centimeter square and separation between the plate 1 millimeter is connected to a battery of 12 volt. The plates are pulled apart to increase the separation to 2 millimeter. A. Calculate the energy flown through the circuit during the process. B. How much energy is absorbed by the battery during the process. C. Calculate the stored energy, the electric field before and after the process. D. Using the expression for the force between the plate, find the work done by the person pulling the plate apart. And E. Show and justify that no heat is produced during this transfer of charge as the separation is increased. So this is initially a capacitor is given which is connected to a 12 volt battery. So we have represented it as a V, and this separation between the plate is D1 initially, and let D1 is equal to D. Now we know that the capacitance of capacitor is given by C equal to epsilon naught A by D, where A is the area of plate and D is the separation between the plate. The capacity will change due to the change in separation between the plate. So C1 equal to epsilon naught A by D1, and C2 will be epsilon naught A by D2, or epsilon naught A by 2 D1, because separation has become twice the initial separation. So we have is 2 D1, so equals to C1 by 2. So charge flown will be delta Q equal to Q1 minus Q2. This is initial charge minus final charge. So initially C1V minus C2V, because battery is not removed, so potential is same. C1V minus C2V, or C1 minus C2 into V, or C1 minus C2 is C1 by 2, so C1 by 2 into V is C1V by 2. Now C1 is epsilon naught A by 2 into d1 1 by 2 into epsilon naught a by d1 into v. So using all value epsilon naught is 8.85 into 10 to the power minus 12, and area is 20 into 10 to the power 2 whole square into 12 by 2 into 1 into 10 to the power minus 3. Solving we get 1.06 into 10 to the power minus 10 coulomb. So this is the value of charge flown. Next, B, energy stored equal to delta Q into V. So 1.06 into 10 to minus 10 into 12, 12.72 into 10 to minus 10 joule. C, stored energy before process 1 by 2 C1 V square, and stored energy after process 1 by 2 C2 V square, because capacitance is changing. So we are using this formula. Initial capacitance is C1 and final is C2. Again D, the electric field at negative plate due to the positive plate, we know that this is our positive plate, this is a negative plate, and E is given by sigma by 2 epsilon naught or Q by 2 epsilon naught A. So the electric field at negative plate due to positive plate is E equal to sigma by 2 epsilon naught or Q by 2 epsilon naught A. Hence, the static force on the negative plate F equal to QE, Q square by 2 epsilon naught A. This will be the attractive force on this negative plate. Now work done will be force into displacement. So W equal to F into D. This we are calculating this work as a magnitude, or Q square by 2 epsilon naught A into D2 minus D1, or equals to Q square by 2 epsilon naught A into 2 D1 minus D1, because D2 is 2 D1. So using we get Q square D1 by 2 epsilon naught A. The work done by the external agent will be positive. If we take this work done as a external agents, then we have to use the positive value. And while the electric force, if work done by the electric force will be negative, and we take that work is done by electric force, then we have to take negative value. Next, 45. A capacitor having a capacitance of